So the functional forms of regression model, it means there are several types of regression model we will deal in our research problem. So these several types of regression models will be used because there are some economic variables that cannot be expressed in terms of linear in parameter or linear in variable. Sometimes some of the economic variables come to our analysis which are not compatible with the existing linear in parameter or linear in variable model. So in that case, we will have to convert those model so that we can apply the OLS method to estimate the parameters of those model. So today we are going to talk, or we are going to discuss about those several types of regression model, which are definitely linear in parameter, but they are not linear in variables. Okay, maybe they are non-linear in variables. That means maybe they are quadratic in variable, cubic in variables. But we will have to we will have to reconstruct them in such a way so that a linear in parameter concept, which is LIP concept, you know that one of the major assumption of the classical linear regression model was the model should be linear in parameter form. That means the parameters B1, B2, B3, and so on, they should be in the linear form. So when any economic variables, for example, elasticity, or GDP growth, or growth of the money supply, growth of the credit in the economy, or population growth. So there are some economic variables which are actually in nature, they are not in a linear form. So these variables are non-linear form. But when we are using them in a linear regression model where the parameters should be in linear form, B1, B2, B3, and all other parameters of the regression model should be in the linear form, we will have to reconstruct them. We'll have to reconstruct those variables. We'll have to reconstruct those variables which are not in linear. It means, for example, as I say, elasticity. Okay. So elasticity is what? Elasticity measures the relative change or percentage change or proportional. Say, if I say that price elasticity of demand, price elasticity of demand. So it means this elasticity actually measures the percentage change in the demand due to the percentage change in price. So both your price variable, which is followed by X, as well as your demand variable, which is followed by Y, both of these two variables are showing the percentage change, not the absolute change. And elasticity measures the percentage change in the demand to the percentage change of the price. So in that case, if we just look at the demand, if we just look at the price elasticity of the demand equation, it is followed by y equal to a into x to the power beta 2. Okay, beta 2, the exponent or power on the x. So from this model, it is very easier to understand that this model follows a variable which is not linear. So this model has a variable which is not linear because it has an exponent which is followed by beta 2. So we will have to reconstruct this model in such a way so that these variables which is found in nonlinear form, it should become in the linear form. Because in that case, our main objective is whatever the types of the variable is, whether it is linear or non-linear, doesn't matter. Our main objective is, according to the first assumption of the CLRM, the parameter of the linear regression model should be in linear. That's why the LIP has been, LIP stands for linear in parameter, okay? Linear in parameter. So our regression model's parameter must be in linear form. Whatever the formation of the variable is, whether it is linear or non-linear, doesn't matter. The matter is whether my parameter is linear or non-linear. If it is linear, then it is consistent with the CLRM assumptions. But if the parameter is not linear, then it is not consistent with the CLRM assumption. So our main objective is today to discuss about those different forms of regression model which are linear in parameter, but they might be non-linear in variables. They are not linear in the variables. So we will talk about those different forms or different types of regression model. So those regression models must be LIP, that means they are linear in parameter, but they may not be linear in variable, LIV. Okay, stands for linear in variable and LIP stands for linear in parameter. So we are going to talk about those different types of regression model. They can be, they may be or may not be linear in variable, but their parameters must be in linear. This is the first condition here we are talking. So what I was giving an example here as per your text, that if you are just given a model like y equal to a into x to the power beta 2, which is actually showing the y means the demand of your product, x is your price of the product. So it is a relationship between demand and price. And when we are measuring the elasticity, this is one of the economic variables. When we are measuring the elasticity, elasticity cannot be measured with a linear regression model like y equals to b1 plus b2x. This one is not applicable for measuring the elasticity, because what? Elasticity measures percentage changes. Elasticity measures percentage changes in the dependent variable, which is y, due to the percentage changes in the independent variable, which is x here. So in your linear regression model, where both variables and parameters are in linear form, there is no percentage. There is no percentage change is shown. What is the change is shown here is the beta B2, which is the slope coefficient in this linear regression model. And this B2 or beta 2 is actually measuring the absolute change. I repeat, this B2 or beta 2 is measuring the absolute change in the dependent variable y due to the absolute change in the independent variable x. Okay. But when we are talking about the elasticity concept, which is one of the major economic variables, and this elasticity always measures the percentage change, or also known as relative change. It does not measure the absolute change. Okay. So elasticity always measures the percentage change, and this percentage change, which is followed by elasticity related to the price and demand, you cannot express this elasticity model in a linear regression form like this, y equal to b1 plus b2x. This model is not applicable. It is not applicable for expressing the relationship between price and demand in terms of elasticity, in terms of percentage changes in the dependent variable due to the percentage change of the independent variable. So what we can do here is we'll have to reconstruct the model in such a way so that it will incorporate the elasticity measures. Okay. So how do we actually reconstruct the model? So this is the first form of the regression model, which is known as linear regression model, log linear model. Log linear model will incorporate the issue of elasticity. When you are given an equation like this, y equal to a x to the power beta 2. So this is a equation where the independent variable x is in the non-linear form, because the highest degree of power on the x is greater than 1 or any value. But if it is equal to 1, then it is actually linear form. But as we are saying that it is a non-linear form of the variable, so definitely the exponent value or power value on the x would be greater than 1. So in that case, how you can incorporate this non-linearity issue in this model so that you can actually incorporate the elasticity issue, and so take the first assumption of the CLRM model that this model should be followed by the linear in parameter form. আর আপনাকে দুইটা জিনিস এখানে খেয়াল রাখতে হবে। আমাকে যে ভেরিয়েবলটা দেওয়া আছে সেটা হচ্ছে আমার নন লিনিয়ার ফর্মে, আমাকে এটাকে লিনিয়ার ফর্মে আনতে হবে, প্রথম কথা। সেকেন্ড ইস্যু হচ্ছে যে আমার যে প্যারামিটারটা থাকবে, that parameter must be in linear form. Okay, and third issue is I have to incorporate the elasticity. I have to incorporate the relative change or percentage change which is followed by elasticity. So এই বিষয়গুলো মাথায় রেখে আপনাকে এই মডেলটাকে রিকনস্ট্রাক্ট করতে হবে। And log linear model is actually showing how a linear model or how a linear regression model has been reconstructed so that all of these three issues, that linear in parameter, linear in variable, as well as elasticity issues are incorporated in this model. Okay. So first of all, what you have to do here is take log in both sides, which is natural log followed by ln. And then as you know that when log has been applied for actually there are two elements, one is a, another one is x. So when log has been applied for two elements and they are in the multiplicative form, you will have to go for their addition form. Okay, like this. And then you know that when there is an exponent on the value of in front of the log, then exponent will come in front of the log. So beta 2 will be here. And now just let log of a is equals to beta 1. So your ln y is equal to beta 1 plus beta 2 into ln x. And this is your log linear model. Now you can see that your variable comes in the linear form, x, there is an exponent by default 1. Your beta 2 and beta 1, both of them are in the linear form because on those two parameters, beta 1 and beta 2, the exponent is 1 or power is 1. So they are in the linear form. Okay, so this is how you can reconstruct your model. But you know that when we are using beta 1 and beta 2, this is actually the population parameter. But actually, we are not estimating the value of beta 1, beta 2. We are going to estimate their proxy values, which is followed by B1 and B2. Okay. So B1 and B2, why? Because we are actually measuring the value of beta 1 and beta 2 in terms of the estimators, which is B1 and B2, because those B1 and B2's values will be estimated based on sample. And when you are adding the EI form, EI means what? Your error term of the model. So in that case, it is known as sample regression function, SRF, with stochastic form or with error term. So in that case, we can say it is a stochastic SRF, stochastic sample regression function. Okay. Up to this, is it clear to everyone how we can reconstruct a price elasticity model into a log linear?
Yes, sir. Yes, sir.
Okay.
Yes, sir.
Our objective is what? We will just estimate the value of B1 and B2 from here. Okay. So how we can write down this? We know that when we are estimating B1 and B2 value in terms of our log of X, so I should say what is X and what is Y here. Let Y is your demand of the product and X is your price of the product, because we know this price is independent, demand is dependent. Demand is dependent on the movement of the price. So in that case, here in this stochastic sample regression function, so we can write down it right like this, that ln y is equals to y hat, ln y hat, y hat, because we know that when we are estimating the parameters from the sample, when we are estimating parameters from the sample, So there is an estimation sign, so which is followed by y hat, and this would be estimated based on the sample, and the value of B1 and B2 will be found according to the calculation of the OLS method or ordinary least square method. Okay. So ln y hat equal to B1 plus B2 ln x. So that is actually replaced here as an ln y hat because B1 plus B2 ln x has been assumed to be ln y hat. This is the estimation we will do. And after that, according to our actual value and estimated value, if there is any difference, then we will get the value of our error term or followed by EI. Okay. So this is what you have already known from your earlier concept from the earlier chapters. So now how you can explain this model. Once you have estimated the value of B1 is say, for example, it is 1.27 and value of B2 is minus 0.0175. Okay, then how actually you are going to explain them? Okay. For the explanation, I'd like to show you that when you are going to explain your estimated values of the parameters from a log linear regression model, they are actually showing the elasticity. What is actually B2 is showing here? B2 is showing here the elasticity. B2 is showing the elasticity. And what actually we know about elasticity? Elasticity means percentage change means delta sign in your y divided by percentage change in your x. Okay, that is what elasticity means. So this percentage change in y means absolute change in y divided by the earlier value of the y. Absolute change in y means the new value of y minus the old or previous value of the y divided by the previous value of the y multiplied with 100. And in the denominator portion, percentage change in x, it means that change in x, which means the difference between new value of x and previous value of x, divided by the previous value of x multiplied with 100. Okay. So this is what elasticity actually measures here. And here, what you have to do is, you know that 100 and 100 has been crossed in the numerator and denominator portion. So what you will have left here, this one, change in y divided by y into x divided by change in x, because these are in the division form. When we'll have take them multiplication form, that would be reciprocal or opposite. Okay. And after that, what you have is change in y divided by change in x divided by y. Okay. This change in y divided by change in x is your slope coefficient. Okay. Because in a classical linear regression model, like y equals to b1 plus b2x, this b2 is the slope coefficient. Okay. And this slope coefficient means how much changes in y has been occurred due to the change of x. This is actually shown by the absolute change in y due to the absolute change in x. This is not the relative form. So when you are measuring only slope coefficient, this shows the absolute change in the dependent variable due to the absolute change in the explanatory or independent variable. I repeat, slope coefficient means absolute change in your dependent variable due to the absolute change in the independent or explanatory variables. Okay, that is why it's been written as slope, and it would be multiplied with x divided by y. So there are so many values of x, so many values of y in your sample. In that case, you'll have to take their average form, x bar and y bar. So we will introduce x bar and y bar later in our calculation. But for now on, just remember that only slope coefficient means the absolute change measurement or absolute changes in the y due to the absolute change of x. But when you are focusing about the elasticity, it means the percentage change in y due to the percentage change in x, which I have written here. So elasticity measures the percentage change or relative change, and slope coefficient measures the absolute change in the dependent variable. Up to this, is it clear to everyone?
Yes, sir.
Yes, sir.
Okay. Now, what I was talking that if you once you have estimated that ln y hat because you have estimated based on sample that your B1 value is found 0.592 plus your B2 value is found 0.0175 and you have ln x. So based on the sample using the ordinary least square method using OLS method considering the partial differentiation approach. So you have estimated that the value of B1 in your log linear model is found 0.592 and your, sorry, there would be a minus sign. Can someone tell me that why I have put down minus sign in front of the coefficient, elasticity or coefficient value of
স্যার যখন
0.0175?
প্রাইস বেড়ে যায় তখন তো ডিমান্ড কমে যায়
Exactly. So the relationship between y and x is negative according to our economic point of view because price and demand are inversely related. So that is why when you are calculating the value of B2, it would be always found negative. If it is not found negative, then definitely there would be a problem in the data. Okay. But according to your economic point of view, the estimated value of the B2, estimated value of your elasticity coefficient would be always negative here. And when you are measuring the price elasticity, this is actually price elasticity. So when you are measuring the price elasticity followed by PE, which is followed by this format, this PE value after calculation would be always found negative. Okay. As I told you that once you have estimated the value of B1 and B2 found this, and how can you actually explain them? The explanation is followed by, first of all, for the B2 value, as B2 value is found minus 0.0175. So it means if X means what? Your price increases by 1%, your quantity demanded followed by Y will be decreased by 0.0175%. Okay. So this is the explanation you will get after the estimation of the B1 and B2 value from your log linear model. Remember that when your B2 value is being calculated, as the relationship between these two variables are economically negative, so the B2 value should have been estimated as negative value minus 0.0175, and it means if price increases by 1%, then quantity demanded followed by Y will be decreased by 0.0175%. As I already told you that log linear model incorporates the issue of elasticity, and elasticity measures the relative change. So your explanation should be in terms of on the basis of percentage or relative form. So the explanation is followed by, if price increases by 1%, that means the independent variables value has been increased by 1%, then quantity demanded or dependent variables value will be decreased by 0.0175%. Okay. And as B1 is equals to 0.592, which means if there is no impact, of the price, on the demand or quantity demanded, still the quantity demanded will be 0.592%. Quantity demanded will be increased by 0.592%. That means the independent variable, which is followed by X, if there is no impact, that means if the value of X is 0, if there is no impact, or if there is no value of the price found, then still the quantity demanded in the economy would be equal to the 0.592%. And this, it is also in the form of the percentage because you know that you have let or you have assumed that ln A equal to B1. So ln log actually incorporates the issue of percentage. So the percentage issue has been assumed to be beta 1, and we are measuring the B1 on the basis of the sample. So the explanation should be in terms of the percentage form. So every explanation here for B1, B2, B3, B4, and so on for the all parameters in this regression model should be in the percentage form or relative form. Now, one thing that you need to remember here, that what is the problem with the earlier model? Why we have to reconstruct the earlier model? Only because of the assumption of the CLRM or because of any other assumption? Because log linear model incorporates the elasticity issue. This is the percentage issue that has not been incorporated by the normal linear model because our variable was not in the linear. And this linearity has been achieved when we have used the log linear model. Okay, both side of the equation has been come up with the log. What I was talking here is why the model has been named after log linear model, because both independent and dependent variable in this model are in the linear log form. Both independent and dependent variables in this model are in the log form. So that's why the model has been named as log linear form. Both of the variables, either dependent or independent variable, both of them would be in the log form. And the model has been also known as double log model. Double log model because, as I already told you, both independent variable y and independent variable x, both of them are in the log form. So that's why the model has been also named as double log model. So what I was saying, that what was the problem with the earlier model? What was the problem with this model? What was the problem with this basic model? Ax to the power beta 2. The problem is when we actually plotting them graphically, we know that our x is here price, our y is here demand, quantity demanded of the product. When you plot them, because of the negative relationship between price and demand, you will get a curve which is like this. So you'll get a curve like this. Why this curve has been drawn here? Because when we are plotting them, when we are plotting this equation, y equals to a x to the power minus beta 2, I have put down minus in front of the beta 2 because the relationship between demand and price is negative. Okay, so if if this equation has been drawn here graphically, y equal to a into x to the power minus beta 2, the sign minus has been given, as I told you, that because the negative or inverse relationship persistent between price and demand. So when you are plotting them graphically, it would be look like a curve. And in this curve, from one point to another point, if you measure the distance, which is known as slope, if you measure the distance, which is shown as a slope from one point on this curve, this slope coefficient is not constant, is not a constant. Because if it is, or if it were a constant slope coefficient, then we could set this model in a normal linear regression model. We should not take the log form in the both sides, okay, to make them in the linear form. If we know that from the equation that this is not a linear invariable model, this is a non-linear invariable model, because the x has the exponent on, or x has the power or exponent, which is followed by minus beta 2. And if we plot them graphically, we will not get a straight line, we will get a curve. In case of the straight line from one point to another point, if you measure the elasticity, that is elasticity, okay? Or if you measure the slope coefficient, that would be constant. For any straight line, if you measure the slope coefficient from one, that means the distance between one point to another point, that will remain constant. But in a curve, when you are measuring the distance from one point to another point, which is known as a slope, this slope coefficient in a curve will not be constant from one point to another point. Say for this point, the slope would be found 0.529. From that point to another point in the downward, if you measure the slope, then this slope's value may be found 0.729, like this. That definitely the slope should be found in the negative form because of the persistence inverse relationship between these two. But if it is a straight line, and if you are measuring the distance between these 2 points, then definitely from each point to another point, or if you calculate the distance middle point and the downward point in the straight line, that slope coefficient would be similar that you have found for the earlier case, that you have found for the earlier distance. So here the slope coefficient will always remain constant, because when you are drawing a straight line, it is followed by a linear equation y equal to a plus bx, or y equal to b1 plus b2x. And if this equation has been drawn graphically, it would looks like a straight line. And in that straight line, your slope coefficient will always remain constant. But if you draw a graphical representation of a equation which is not linear in the variable, like y equal to a into x to the power minus beta 2, then it would be like a curve. And this curve, for this curve from one point to another point, if you're measuring the distance, the slope coefficient is not constant here. You get a coefficient different number from one point to another point. Okay, but for a straight line, you will get the constant slope coefficient. So when we have applied the log form in the both side, when we have applied log form in both side, in the dependent variable side as well as in the independent variable side, like this, when we have reconstructed the model in using the log form, and we have found that this is our final model, this is our final model, ln y hat equal to b1 plus b2 ln x. And if you plot them graphically, it would be a straight line. And for this straight line, your elasticity coefficient, I would like to say it's elasticity coefficient, because why? Elasticity has been incorporated the issue of percentage, incorporated the issue of relative change. So when you have graphically plotted this log linear model, you will get a straight line, and in this straight line, for every point, from one point to another point, from another point to other point in the downward value, then you will get a constant slope. And this is known as constant elasticity slope. Constant elasticity slope coefficient. And that is why we have to reconstruct the earlier model y equal to ax to the power minus beta 2 using the log model, using the log form in both sides, so that it would be a straight line and its slope coefficient will remain constant in the form of elasticity. Is that clear to everyone?
Yes, sir. Yes, sir.
Okay. Now, for any log linear model that incorporates a multiple factor, okay, for any log linear model that incorporates a multiple factor, that means for a multiple log linear model, how do you explain them? Multiple log linear model. So in a multiple log linear model, definitely there will be more than one explanatory variables. And once you have estimated the parameters of those multiple log of those explanatory variables incorporating the multiple log linear model, then how do you explain them? So let's take an example from your text. And first of all, it is the data that you are given in your page. This is in the page of 141 in the 4th edition of your text, and in the 3rd edition of your text, the page number is 257. Okay. So this is the data you are given. You are given the real GDP value, the employment, and the fixed capital. We know that Cobb-Douglas production model, where our output or the amount of output is our dependent variable, and here the amount of output has been estimated with the real GDP from the year 1955 to 1974. Okay, and in your third edition model, maybe the data set starts from 1960 to 1980. পেয়েছেন সবাই?
Yes, sir.
Okay.
স্যার এটার মতোই।
So I am also showing it from the fourth edition of the text. So this is the data set you are given. Okay, now considering this data set, if you have been asked to estimate a log linear model, which is actually related to the Cobb-Douglas production model, because Cobb-Douglas production model estimates the output of your total production output in the economy, which is followed by inputs. And there are two inputs. You know that there are 4 factors of production, but out of those 4 factors of production, only 2 factors of production have been considered here. One is employment, another one is capital. 4 factors of production: land, labor, capital, and entrepreneurship. So here, employment means the labor, fixed capital means the amount of capital you have injected in the economy, and the GDP is the total output or the total level of production in the economy. Okay, and these 3 variables, GDP is the dependent variable. You can easily understand that because we are estimating the total output level or production level according to the Cobb-Douglas production model, and our input variables are employment, which is followed by the labor input, and the fixed capital, which is followed by the amount of capital input. And after that, using this data, once they have inserted in the stata, they have found the output is this. Okay. Now here, I will show you how they have calculated in the stata. This is the total data set, which is written in the Excel. So first, copy the data from the Excel sheet. Then you will have to paste it in your stata. Okay, what kind of data it is? Cross-sectional, time series, or panel data? এই data setটা যে দেওয়া আছে, এটা কি ধরনের data বলেন তো?
স্যার প্যানেল ডেটা।
Panel data. So if it were a panel data, then definitely there would be GDP for country 1, then for GDP, employment, and fixed capital for country 2, for country 3, and so on. But there is only one country's GDP, employment, and fixed capital is given.
Oh, yes, sir.
Time series data.
Sorry?
Time series data.
Yes, it's the time series data. So, so let me show you how this time series data would be analyzed using this data. First of all, as I told you, you have to copy the data set from the Excel, then start your stata dialog box, then paste the data in the data editor. You are pasting the data using Ctrl+V. You have been asked that treat first row as the data or treat first row as the variable name. So you will click on the second option, click first row as the variable name. Okay. So you can see that your data set has been already taken in the stata. Now you'll have to make stata understand that this is a time series data. Stata ke eta bujhate hobe. Stata ager theke eta কোনো অবস্থাতেই stata will not recognize that this is a time series data by default. Okay, you'll have to give some instructions, some command to make him understand that this is a time series data, and you'll have to analyze it. So first of all, to make him understand, you'll have to write down a command that ts set time series data set space year. Year is the variable which is showing that this is a kind of time series data. So they have taken time variable from 1955 to 1974. Only 1 unit of time variable has been taken. Okay. And after that, you know that these GDP, employment, and fixed capital are given in the absolute value. Okay, but what you have to do here, you'll have to analyze these data with a regression model, which is should be in a log linear form or double log form. That means both of your dependent and independent variables should be in the log form. Okay, because you have to incorporate the percentage concept here. That means you are going to show that how much percentage changes in your GDP happened due to the percentage change in the employment or due to the percentage change in the fixed capital. Okay. So for that, how do you make the command that will constitute the estimation of the log linear model? So here you have three variables: GDP, employment, and fixed capital. So what you have to write down: generate GDP2. That means you are creating a second variable of the GDP, which is followed by LN. Then stands for natural log. Log to দুই রকম, এটা জানেন তো না? One is natural log, another one is আরেকটা কি?
Sir, normal log.
Common log. Okay. So natural log, the identification of the natural log is its base is always E, and for common log, the base is always 10. Okay, by default, the base is 10. So when we are writing ln, it stands for natural log whose base is E, and this would be multiplied with GDP. ln with GDP. First parenthesis closed, and then press enter. So you can see the list of variables GDP2, another variable of the GDP, has been created with a log form. Okay. Similarly, you'll have to create the log form of the other two variables, employment and for also fixed capital. Considering this command, generate GEN employment2 is equal to ln starting of the first parenthesis, closing of the first parenthesis, the first bracket, employment. And then similarly, you'll have to create the third variable, generate fixed capital 2, which is in the non-log form now. Now you're making them in the log form. So in the list of variables, now you can see that there are three other variables created. One is GDP2, another one is employment2, another one is fixed capital 2. Okay. সবাই দেখতে পাচ্ছেন তো না?
Yes, sir.
Now you have to run the normal regression command. REG stands for regression. Your dependent variable is the log of GDP, which is showing the log of total production or output of the economy. Your independent variables are the two inputs of the output, two inputs of the in the economy. One is log form of the employment2, and another one is log form of the fixed capital. And then press enter. Okay, so you can see the output has been generated, and here the GDP2 is your dependent variable, which is the log of GDP, and your employment2, fixed capital2, these are your log of employment, log of fixed capital respectively. Their corresponding coefficients created. Sorry, standard error value is also given here. T-table value is given here, and p-value is given here. So according to the p-value, you can say that employment2, which is the log form of the employment, is found statistically significant for 10% level, but in the 5% level, it is not statistically significant because the value of p is greater than 5% here. Okay. For the another variable, fixed capital2, it is found statistically significant at the 5% level. The constant is also found significant at the 5% level. So this is the output. We can see here that this coefficient value is 0.3397 for the employment2, 0.8459 for the fixed capital2, and for the constant, it is minus 1.6523. Okay. And if you just look at the output given in your text here. So is it similar? minus 1.6524 is the output of the constant, দেখতে পাচ্ছেন?
Yes, sir.
And 0.3397 is the value of your B2, value of your parameter, which is also given in your output, 0.3397 for the employment. That means log form of the employment. ln x2, x2 is here employment. And for the log form of fixed capital followed by x3, it is 0.8460, which is also here as 0.8459. That means 0.8460. Okay, so the output we have generated, it is consistent with the output given in your text. Okay, and here the explanation is as same as we have already explained in the earlier case. Your explanation should be followed by percentage form. So how do you explain? Explanation is if employment, or I can say if the labor input has been increased by 1%, then the output followed by GDP will be increased by 0.3397%. Or if the fixed capital, which is increased by 1%, then the output GDP will be also increased by 0.8459%. Okay, and if there is no impact of the employment and fixed capital, is still the GDP or output level would be equal to minus 1.6523. So it's very consistent with our economic theory that if there is no input in the economy, if there is no employment, if there is no capital injected in the economy, then who is going to produce and how the production will be happen? So there will be no production. So your production becomes negative in that case. And that is why your constant is showing the negative value, 1.652345%. Is that clear to everyone? Okay.
Yes, sir.
Yes, sir.
Yes, sir.
Sir, what
Okay.
can be inferred by negative production?
Sorry?
What can be inferred by negative production?
As I already told you, that negative production means it does not have, there is no one in the economy to produce anything. That means your production is physically zero. There is no production. But because of the mathematical data here, it is found negative. And it is showing that if you have the earlier production output, which is already going on, those production output would be deteriorated day by day if there is no further input from the employment, no further input from the capital.
Okay, sir. Thank you, sir.
Okay. Okay, just a minute. Just give me 1 minute. Someone is knocking at the door. Okay. Okay. Okay, so as we are continuing with this example, there is another findings with this example, that is, you know that from your concept of the microeconomics, return on a scale, there are 3 types of return on a scale: constant scale, increasing scale, and decreasing scale. Okay, so when Cobb-Douglas production model has been generated with this data in terms of our statistical output, then this has an implication. For any multiple linear regression model, especially for the multiple log linear model here, we are talking about the log linear model, multiple log linear model. In any multiple log linear model, if it is followed by like this, ln equal to b1 plus b2 ln x1 plus b3 ln x3 x2 plus b4 ln x3. So if it is followed by the 3 explanatory variables who are in the log form, sorry, all of them are in the log form, and your dependent variable is also in the log form, it is a multiple log linear model. When you're explaining them, remember one thing, you will have to add one line, which is ceteris paribus, or which is also known as holding the impact of the other variable as constant. Okay, holding the constant impact of the other variables. Okay, for example, as I was explaining that if the employment opportunity has been increased by 1 percentage point, then definitely your GDP of the country will be increased by 0.3397%, provided that the impact of the other variable, that means provided that the impact of the fixed capital variable will remain constant. Okay, which actually means, or in summary, it means that when you are explaining the multiple log linear model, remember always that you are explaining only the partial elasticity coefficient or partial coefficients, because the word partial added here because you are assuming the impact of other variables or the impact of the other parameters of the variable remain constant. When you are explaining the variable x1, you are assuming that the x2 and x3 remain constant or held up. You are not going to explain them simultaneously. You are explaining only x1, considering the impact of x2 and x3 remained constant or held up. So that is why the B2, B3, B4, all of these elasticity coefficient are known as partial. B2, B3, B4, all of them are partial elasticity coefficients. Okay. Only elasticity coefficient will be sage when you have only one explanatory variable. That means in the earlier case, when we are saying the price elasticity of demand, then we have used only elasticity word. But now when you are explaining the output of the multiple log linear model, then you have to, you definitely will have to add the word partial in front of the elasticity, because you are explaining only one variable or considering the held up of the other variables impact constant. Okay. So this is one thing that you need to remember while explaining each of the parameter value in the multiple log linear model. And in this example, what we have found, there are two inputs in our production. One is employment, another one is fixed capital. I told you that there is a findings from these two inputs. When we add the coefficient of these two inputs, one is employment opportunity, another one is fixed capital. Their coefficients are, one's coefficient is found 0.339. This is the coefficient from the B2. Another coefficient B3 is found 0.8459. 0.8459. If you add these two coefficient value 0.339 plus 0.845, it would be greater than 1. Okay, this greater than 1 has an implication. This greater than 1 has an implication. The implication is increasing return of scale. Increasing return on scale. I think you can recall the concept of the return on scale from your microeconomics.
No, sir. No, sir.
Why?
I actually forgot that concept.
Okay, the concept is very simple. If you have 4 factors of production, you have 4 inputs. You have land, you have labor, you have capital, you have organization or entrepreneurship skill. When you have these 4 inputs, so giving insert of these 4 input, or by giving insert of these 4 inputs, either land, labor, capital, and organization, how much your output will be increased, whether it would be increased as a double form or more than double form or less than double form. Okay, that is known as return on scale. That means you have given input of these 4 component and how much return or how much output you will have in a double form. Sometimes we will explain it as when the value of return on scale is found greater than 1, it is known as increasing return on scale, which means doubling the input will produce more than double output. Okay, so when the return on scale value is found greater than 1, it is known as increasing return on scale. And this increasing return on scale actually means doubling the input in your economy of the factors of production will produce more than double output. Or if the value of your return on a scale, which is found by the summation of the coefficient of those input. So we have used here only labor, which is formed as an employment. Another one is capital, which is formed fixed capital here. So this fixed capital and employment, for the employment, our coefficient value is B2. For fixed capital, the coefficient value was B3. So when we have added their elasticity coefficient, one is 0.339, another one is 0.845. When you have added all the inputs elasticity coefficient, there are two inputs we have used. So one is employment, another one is fixed capital. So when you have added these two inputs elasticity coefficient, it's found than 1. 0.339 plus 0.845 definite would be produce a value which is greater than 1. And that actually means increasing return on a scale. And this increasing return on a scale, which in plain English, it means if you have doubled the input of your employment as well as in your fixed capital, this will produce more than double output. That means if you have increased it 2 times, it will produce more than 2 times output. Okay. So that is what the findings and other findings we have found from this explanation. So the first one is, I told you that one is partial elasticity coefficient. All the coefficients in the multiple log linear model are said to be partial because you are explaining one coefficient considering the held up of the other coefficients as constant, or other coefficients impact will remain constant. And second one is return on a scale. That means if you have doubled the input of your production, or if you, sorry, the input of your economy in the economy of the production, then how much your output in the economy will be increased, whether it would be increased more than double or less than double. For example, in this output, if the value of our parameters and the summation of their parameters value is found less than 1, then if it is found less than 1, it is known as decreasing return to scale. And decreasing return to scale means the opposite of the increasing return on scale. So that means doubling the input will produce less than double output. So if you have increased the 2 times input, it will not produce exactly 2 times. It will produce less than 2 times output in your economy. And if it is exactly equal to 1 found, that means the summation of the parameter value, B2 and B3 value, their summation is found exactly 1, then it means constant return on scale. Constant return on scale. So it means constant return on scale. Constant return on scale means if you have double the input in your economy, that will produce exactly double output in the economy. So that is constant return on scale. So that is the explanation regarding the return on scale. It can be of 3 types: increasing, decreasing, and constant return on scale. I think it's pretty clear to everyone. So, বুঝতে পারছেন তো?
Yes, sir.
Yes, sir.
Okay. Then let's solve a problem from our text regarding the log linear model. This is from the problem number, first problem number 4.5.10 from the 4th edition, and from the 3rd edition it is 9.10. পেয়েছেন সবাই? Page number 281.
Yes, sir.
Problem number 9.10 or 5.10 from the 4th edition. So you are given here 2 model. One is model A, another one is model B. So in the model A, it is just a linear in parameter and linear in variable form. So you are given, let me write down model A equal to 2.6911 minus 4.795 into xt. So here there is no log form in both sides of the model. So this is just a simple linear regression model. So the variable is here in the linear form, and definitely the parameter also in the linear form. And you are given the standard errors also, the corresponding standard errors or standard deviation for each of the parameter. One is given 0.1216, another one is given for the B2. The standard error is given 0.1140. And your R square value, which shows the coefficient of determination or the goodness of fit of the fitted model, or the fitness of the model, how good is the model is, that is R square equal to 0.668. Then for model B, ln yt hat, this is in the log form in the dependent variable, and also in the independent variable is found in the log form, minus 0.2530. Standard errors are also given 0.0152, and another one is 0.0494, and R square value is given 0.7448. Okay, now you are given that y equal to cups of coffee consumed per person per day, and X means your price of the coffee in dollars per pound. Very simply, actually, Y is the coffee consumption and X is the price of the coffee, okay? So if first of all, you have been asked to interpret the slope coefficient in these two models, slope coefficients only, not the intercept coefficient. So you have been first asked to interpret the slope coefficient. So from model 1, model A, the slope coefficient B2 is equals to 0.4795, which means if price of coffee increases by কি হবে বলেন তো 1% হবে না 1 unit হবে?
Sir, 1 unit হবে.
Exactly, because the linear regression model without log form is estimating the slope coefficient of the linear regression model without log form will estimate the relative absolute change, not the percentage or relative change. Okay, so as we are dealing with the absolute change, so if the price of the coffee increases by 1 unit, then the coffee consumption will be decreased by 0.4795 unit. Okay, 0.4795 unit. From model B, the B2 value is minus 0.2530. So its explanation is if price of coffee goes up by, সংক্ষেপে লিখছি আর কি, আপনারা লেখার সময় আবার এরকম সংক্ষেপ ইউজ করেন না, মানে for my ease of writing I have just used the upper sign, which means the price increases by 1 percentage point, consumption decreases by 0.2530 percent. 0.2530 percentage, because this is the log linear model that incorporates the elasticity, which shows the relative or percentage change in the dependent variable y due to the percentage change in independent variable or explanatory variable. Okay, so the first one, I think it's clear to everyone. Then for the second part, in the number B, you are told that y bar equal to, okay, y bar is equal to 2.43, 2.43, and x bar equal to 1.1. At these mean values, estimate the price elasticity for model A. For model A, We know that model A is a model which is simple linear regression model, where there is no log form. And you have been asked to measure the elasticity for model A. So for model A, the elasticity, which is actually which will be actually calculated based on the average values of y and x. So we will consider them average elasticity of model A. It is equal to the derivation I showed you earlier. Why we have used the log linear form from a non-log or non-linear regression model. আমি যে এখানে একটা derivation দেখিয়েছিলাম যে this is a non-linear regression model, and for this non-linear model we have to use the log form in the both side to incorporate the elasticity issue. And then I have also shown you that when we are measuring the slope coefficient, when we are measuring the elasticity coefficient followed by P, this is showing the percentage change in Y due to the percentage change in X. And here, after the calculation, the last line, I have given here the slope multiplied with X by Y. I told you that there would be more than one values of X, more than one values of Y. So we will have to write down it like this: slope into X bar divided by Y bar. But we'll have to measure this elasticity considering one value of X and one value of Y. But in practice, you will get the data set where the X value will be more than one, Y value will be more than one. And X এর অনেকগুলো ভ্যালু থাকবে। X হয়তো বা আপনার টোটাল ডেটা সেটে 15 বছর দেওয়া আছে, তাহলে X এরও 15টা ডেটা থাকবে, Y will also have the 15 data. তাহলে আপনি তো 15টা ডেটা দিয়ে এখানে বারবার স্লোপকে মাল্টিপ্লাই করতে গেলে it will be a cumbersome calculation for you. That's why you have taken the average of X and average of Y. Is that clear to everyone?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So in that, the same one would be applied here because our earlier model was not in the log form, but when we have incorporated the log form, I told you that log form incorporates the elasticity concept. And when we are measuring the elasticity, it would be followed by this one: average elasticity is equal to slope coefficient multiplied by X bar divided by Y bar. From model A, the slope coefficient was what? Model A slope coefficient কত ছিল? দেওয়া আছে এখানে দেখেন, model A slope coefficient হচ্ছে -0.4795. So right here -0.4795. X bar value is given কত? 1.11.
1-1.
Y bar value is given 2.43. Okay, now calculate these values. কত আসে দেখেন। কত আসছে? মাইনাস তো অবশ্যই আসবে because you are estimating the elasticity.
-0.2190.
-0.2197.
2190.
90. Okay, -0.2190. So that is what you have been asked to estimate the elasticity for model A. আচ্ছা, মডেল B এর elasticity কেন মেজার করতে বললো না? It's already given, তাই না? নাম্বার C তে আপনাকে জিজ্ঞেস করেছে, দেখেন, what is the price elasticity for model B? Model B, if you look at the model B, it is already in the log form. So in the log form, log linear model always incorporates the elasticity. So the coefficient value is given here. So the coefficient value -0.25330 given in this model or estimated in this model, it's already in the elasticity form. It's already in the elasticity form. So that's why the answer C, price elasticity PE for model B is equal to -0.2530. এটা বুঝতে পারছেন তো? মডেল বি এর জন্য আমি কেন আর এই ফরম্যাটটা ইউজ করলাম না, কেন ইউজ করলাম না একটু বলেন।
স্যার কারণ আমি যদি লগ মডেল ইউজ করছি, লগ মডেল এজিউম করে যেটা প্রাইস ইলাস্টিসিটি ইনকর্পোরেট করে।
হ্যাঁ, মানে ইলাস্টিসিটি অলরেডি এটা ক্যালকুলেট করেই দিয়েছে। ইলাস্টিসিটি ক্যালকুলেট করে ইটস ফাউন্ড at -0.2530 because in any log linear model the slope is not only called slope, it is called elasticity coefficient. Okay, এখানে আমরা এটা কিন্তু স্লোপ ডাকিনি, এটাকে ডাকি হচ্ছে elasticity coefficient -2.30 টাকে। So it's given already, and then number D.
এর পরে আরেকটা আছে যেখান থেকে রাস্তাটা বাইপাস হয়েছে।
Number D, from the estimated elasticities, can you say that the demand for coffee is price inelastic? যে elasticity আপনি ক্যালকুলেট করলেন for both model A and B. Okay, for model A, elasticity is found -0.2190. Okay, fine. For model B, it's already calculated -0.2530. So can you conclude that it is elastic or inelastic, or perfectly elastic or perfectly inelastic, or no elastic?
সেটা পার্সেন্টেজ চেঞ্জ ইন ওয়াই ডিভাইড বাই পার্সেন্টেজ চেঞ্জ ইন এক্স ওভার বের করতে হবে না?
দেওয়াই তো আছে, -0.2530 দেওয়া আছে না? আমরা যখন ডিমান্ড কার্ভটা ড্র করি, মানে যখন আমরা
স্যার এটাতে ইলাস্টিক
ইলাস্টিক, আচ্ছা
Yes,
এখানে
sir.
যেখানে আমাদের মিডল পয়েন্ট অফ দ্য ডিমান্ড কার্ভ, এখানে আমাদের পি টা হচ্ছে অলওয়েজ 1. If you go to the upper side of the demand curve, then here the value of elasticity is greater than 1. The value of elasticity is less than 1. When the value of elasticity is greater than 1, this is elastic. Okay. When it is exactly equal to 1, it is unitary elastic. Okay. When it is less than 1, it is inelastic. Okay. So this is the middle point where the equilibrium happens. Okay. At the equilibrium point, it is known as unitary elastic. If the value of elasticity is found greater than 1, it is elastic. If it is less than 1, it is inelastic. আর যেটা আপনি বলছেন, কি একজন বললেন যে এটা ইলাস্টিক বলছেন, ইলাস্টিক বলছেন, আপনি হয়তো ধরে নিচ্ছেন যে 0 থেকে ছোট হলে আপনি বলছেন সেটাকে ইনএলাস্টিক, আর 0 থেকে বড় হলে সেটাকে ইলাস্টিক বলছেন। আসলে তা না, 0 যদি হয় সেটাকে আমরা বলি পারফেক্টলি inelastic. Perfectly inelastic. Okay. মাইক্রোইকোনমিক্সটা একটু রিভিউ করে আসবেন সবাই নেক্সট ক্লাসে, বুঝছেন? তো পড়ছিলেন তো অনেক আগে, তাই না?
জি স্যার।
That's right. Perfectly inelastic. সেই ক্ষেত্রে when the demand curve is perfectly inelastic, it would be a horizontal vertical line. Okay. মানে at any level of price, your demand is constant. কোনো চেঞ্জ নাই ডিমান্ডে। Clear? So here your value is elasticity valueটা কত আসছে? Minus কত আসছে? 0.2530. Okay, it is less than 1. So we can say, এখানে আবার খেয়াল করেন একটা বিষয় যে মানে -0.2530 আসছে, এটা তো less than 0 হয়ে গেল। তো এটা কিভাবে সম্ভব হচ্ছে? মাইনাসটাকে আমরা কনসিডার করি না, আমরা যখন এখানে গ্রাফিক্যালি কনসিডার করছি there is no minus value. মাইনাস ভ্যালু হলে আমরা কিন্তু এটাকে নিচের দিকে লিখবো। ওকে, তো because the graphical representation the minus values comes in the lower part, এখানে আমরা আপার পার্ট নিয়ে কথা বলছি। তো সেই ক্ষেত্রে আমি বলছি যে যখন আপনি when you are comparing the mathematical elastic value with the graphical value, তখন আপনি মনে রাখবেন যে ম্যাথমেটিক্যাল ভ্যালুটার যে সামনে যে মাইনাসটা আছে, এটা এখানে আমরা তখন we will not consider this minus value here in the mathematical calculation. We know that the relationship is negative, so any mathematical value for the elasticity will be found in the negative form. Okay, so সেই কারণে যখন we are plotting them graphically, we are showing here the graphical representation which is in the upper part of the graph. Upper part of the graph is always showing the positive value, and lower part and the left hand side of the graph showing the negative values. Okay, আমরা তো এখানে মানে ওই সাইডে দেখাচ্ছি না, আমরা শুধু দেখাচ্ছি হচ্ছে right hand side, so which combines all positive values here. So সেখানে খেয়াল রাখবেন always যে when the value is found less than 1, it is inelastic, equal to 1, unitary elastic, and greater than 1 is found plastic. So আমাদের value আমরা if we just do not consider here minus sign, ধরে নেন এখানে minus signটা নাই, then we can say the value is found less than 1. So if it is found less than 1, then the elasticity for this coffee consumption according to the output of model B is inelastic. Okay. এতটুকু বুঝতে পারছেন কিনা বলেন?
Yes,
Sir,
sir.
this means
Yes, sir.
consumer buying habit remains unchanged.
Yes. Sorry?
Sir, this means consumer buying habits remain unchanged.
Unchanged, exactly. Yeah. This is
Sir,
actually
এখানে-
given from the output, and that is the conclusion we can draw here, that the demand for the coffee is actually inelastic here, even if the price has been changed. Okay. So we can write down the conclusion here in the part D. From the estimated elasticities, can you say that the demand for coffee is price inelastic? Yes. Demand for coffee is price inelastic. Okay. Then we can get to the lower part. That means in the part E. গ্রাফটা কি মুছতে পারি? মুছে ফেলি?
Yes, sir.
Okay. In part E, you have been actually asked, how would you interpret the intercept in model B? How do you interpret the intercept? Now come to the point of intercept. So long we have talked about discuss about the slope coefficient, elasticity coefficient in these both models. But now in model B, the intercept value is found 0.774. 0.774. What is the explanation of this? কি হবে বলেন তো একটু? As
Sir,
B1 equal to found 0.77, হ্যাঁ বলেন, 0.774. It means what?
sir, price যদি আমার 0 হয় তাও আমার consumption সেটা remain করবে 0.774%.
Okay. So if there is no impact of the price, then price means 0. Then still your consumption of the coffee will remain 0.774 or remain at 0.774%. So that is the explanation you have to write down. And then for F, আচ্ছা এখানে ইতে একটা জিনিস আপনাকে নিতে বলছে, যদি আপনি এটার একদম এক্সাক্ট মানে অ্যাবসলিউট ভ্যালু চান, B1 equal to যেটা লেখা আছে B1 equal to 0.774, when you are explaining it, you'll have to explain it in terms of the percentage form. But if you want to take it in the absolute form আপনি এটাকে নিতে পারবেন। এটা হচ্ছে এরকম যে we know that আমরা when we are assuming beta 1 from the model, what we have taken, আমাদের যে মডেলটা ছিল একদম প্রথমে আমি যেটা শুরু করেছিলাম y equal to ax to the power beta 2, এখানে this is our initial model of the elasticity, and then we have let ln a equal to beta 1, and beta 1 has been estimated with a proxy parameter which is b1. Okay, so I can write down that b1 equal to ln of that, b1 equal to so b1 equal to ln of a, which is equal to 0.774, or a equal to 1 by ln. 1 by ln কে আমরা জানি কি বলি? এটাকে আমরা কি বলবো? Antilog. If we take the cross of the log, লগের যদি ক্রস নেই তাহলে এটাকে কি বলে? Antilog বলে, এটা ভুলে গেছেন? So how can you calculate the value of antilog? সবাই শুনতে পাচ্ছেন তো আমাকে?
Yes, sir.
Okay.
Yes, sir.
So how can you calculate the antilog? ক্যালকুলেটরে যাবেন, ওই যে শিফট যেখানে লগ আছে সেটার উপর একটা 10 করে লেখা আছে, দেখতে পাচ্ছেন? ক্যালকুলেটর আমার কাছে নাই এই মুহূর্তে। সো আপনারা যেটা করবেন, those who have the scientific calculator, you have two buttons there. One is shift, another one is lock. So press shift first, then lock, which will bring the anti-lock, and then you have to write down in the first bracket 0.774. You will get the answer. So that is actually showing the absolute value. So if it means if there is no impact of the price, if there is no impact of the X, which is followed by price, consumption of the coffee will be equal to that amount. ওই absolute value টা হচ্ছে amount of coffee consumption, which is not in the percentage, which is in the absolute value. Okay.
Yes, sir.
So the value you will get there, this is the absolute value of coffee consumption. Okay, then come to the point of number F. So in number F, you are said that since the R square for model B is larger that of model A, model B is preferable to model A. Comment on this statement. ওরাই comment করেছে যে R square value for model B is showing R for model B হচ্ছে 0.7448, and R square for model A is given 0.6628. So this R square value, you know that coefficient of determination, which actually means that the variation in your dependent variable, that means your dependent variable is your coffee consumption here. The variation in the coffee consumption will be explained by the movement of price of the coffee. Okay, so here R square for the model B is found 0.7448, which means 74.48% variation in Y, that means coffee consumption, is explained by X or price of the coffee. Okay, and also will be similar for 66.28% variation in the coffee consumption would be explained by X in model A, that means in price in the model A. But they have asked you that because the value of the R square in model B is found greater than the value of the R square in model A, so they have made a comment that model B is superior to model A because of the R square value. So how do you justify this comment, or whether you are actually agree with this model? If you do not agree with this statement, then how do you justify your disagreement with this statement? কোয়েশ্চেনটা বুঝতে পারছেন তো না? তারা বলেছে যে R square value of the model B is higher than the R square value of model A, so we do prefer model B than model A. So whether they're correct or not, you have been actually asked to justify here. এখানে মনে রাখবেন, when you are given the raw data of Y and X, এই জাস্টিফিকেশনটা মানে যেভাবে বলেছে যে R square এর উপর ডিপেন্ড করে তা কিন্তু না। Yes, R square would be a major catalyst in determination of the goodness of fit of the model if both model have the dependent variable in same form. I repeat, R square would be a better catalyst to determine the goodness of the model if both models dependent variable are in the same form. You can see that from model A does not belong to log form. Model A in the question, the output generated from model A, it does not belong to the log form, either in the explanatory variable or in the dependent variable. But in model B, both of the dependent as well as the explanatory variable are in the log form. So R square cannot be a catalyst for making a comparison between two models which are different in the formation, which are different in their model formation. দুইটা তো সেম মডেল না, আপনি আর স্কয়ার দিয়ে কিভাবে এখানে কম্পেয়ার করেন? আমার কথাটা বুঝতে পারছেন? যে হ্যাঁ, আর স্কয়ার would be a good estimator, or r square would be a good catalyst for the comparison if both model are in the same form. If both models, dependent variable and independent variable, are in the same form, সবগুলা মডেলের যদি বা এই দুটা মডেলের যদি dependent variable same ফর্মে থাকতো, যে both of them are in the log form, then r square would be best approach. Or both model are in the linear form, then also r square would be the best approach. But when one model in the linear form, another model in the log linear form, then r square, depending on the r square, or always choosing model depending on the r square, would be the wrong decision being a researcher. Okay. In that case, what would be the conclusion? Or how conclusion means you have already drawn the conclusion from my discussion that you are not going to agree with their statement. Okay, তাদের যে স্টেটমেন্টটা দিয়েছে যে model B is superior to model A, or model B is preferable to model A, that is not consistent with your discussion, with your explanation. তাহলে কি করতে হবে? You will have to justify your statement. You are disagreeing with them. So when you are disagreeing with their comment, you are disagreeing with their justification, then how do you make your justification in favor of your statement? তাহলে আমরা যেটা জানলাম প্রথমে যে r square would be the best approach when both models are in same form. Here, model A follows linear form and model B follows log linear form. In that case, or in this regard, choose model or choosing model depending on r square would be a wrong decision. Okay, would be a wrong decision. এতটুকু আপনার explanation শেষ, কিন্তু আপনাকে জানতে হবে যে how you can make the comparison between two model which are not in the same form. তাহলে আপনি compare করবেন কিভাবে, which model is better or which model is better fitting the data. আপনার স্যাম্পলের ডেটাকে বেটার ফিট করছে কোন মডেলটা, এটা আপনি কিভাবে বুঝবেন? From the very beginning, when you are given the data set, the first approach is when you are given the data set, plot y against x. When you are given the data set, plot your dependent variable against your independent variable. Okay. If you see that the relationship is almost linear between y and x, graphically যখন আপনি প্লট করেন দেখলেন এবং x এর মধ্যে লিনিয়ার রিলেশনশিপ পাওয়া যাচ্ছে, মোটামুটি লিনিয়ার আছে, অলমোস্ট লিনিয়ার বলা যায় এরকম. In that case, definitely your linear model would be preferable to the log linear model. But after plotting y against x, if you have found that it is a little bit this one curvature, okay, the graphical representation between y and x looks like a curve. In that case, you cannot fit the data using a model which is linear model or linear in variable model. That means you cannot fit the data using a straight line model or linear form model. What you have to do there is to use a log linear model. And in that case, again you'll have to plot ln y against ln x. And after plotting them, after plot log of y against log of x, if you have found that yes, now it is a straight line, then your log linear model would be better or preferable to your linear model. I repeat, when you plot only y against x, that means your raw data of y against your raw data of x, and if you have found almost a straight line, then your linear model would be preferable to the log linear model. But after plotting the raw value of y against the raw value of x, if your model looks like a curvature relationship, or if your graphical representation shows a curve between y and x, so in that case, you have to understand that this linear model will not be applicable for this set of data. It is actually followed by a non-linear model. So for a non-linear model, I told you earlier, because of the assumption of the classical linear regression model, a non-linear model must have to be reconstructed into a linear model using the log form in both sides. Non-linear একটা regression model কে আপনি linear এ আনতে হলে log use করতে হবে, এবং in that case once you have used the log form in the both side of the dependent variable and independent variable, plot them. Plot log of y against log of x. And after plotting them, if you have found a constant elasticity line, that means your elasticity is constant, because when you have found a straight line after plotting log of y against log of x, this is your x, this is your y. Here you are plotting log of x with log of y and found a straight line, then you are 100% certain that log linear model is more preferable to the linear model in this data set. Is that clear to everyone?
Yes, sir.
আচ্ছা,
স্যার একটা কোশ্চেন ছিল, তাহলে স্যার
বলেন।
এখানে 11টা অ্যানুয়াল অবজারভেশন, তো এখানে দুইটা মডেল কি জন্য ইউজ করছে?
দুইটা মডেল ইউজ করার কারণ হচ্ছে কি, আমরা এখন কম্পেয়ার, যে আমি এখন ডিসকাশনটা শুরু করেছি, যে একটা হচ্ছে লিনিয়ার মডেল, একটা হচ্ছে লগ লিনিয়ার মডেল, ওরা দুইটা দিয়ে আউটপুট দেখিয়েছে। কোন মডেলটা বেটার ফিট করছে ডাটাকে, সেটা জানার জন্যই কিন্তু তারা দুইটা মডেলে ডেটাগুলোকে ফিট করেছে। কোন মডেলটা বেটার আপনি এখনই জানতে পারবেন এইভাবে, যে আমার নেক্সট পয়েন্ট অফ ডিসকাশন থেকে, কারণ ইউ আর নট গিভিং দ্য র ডাটা, এখানে কিন্তু র ডাটাটা দেওয়া নেই, আপনাকে শুধু আউটপুটটা দেওয়া আছে। কথা বুঝতে পারছেন? যখন আপনাকে র ডাটা দেওয়া থাকতো, ইফ ইউ আর গিভেন দ্য র ডাটা, দেন ইউ ক্যান অ্যাপ্লাই দিস অ্যাপ্রোচ হোয়াট আই হ্যাভ জাস্ট ফিনিশড, যেটা আমি বললাম, যে প্লট করে আপনি বুঝতে পারতেন যে আসলে কোন মডেলটা এখানে বেটার ফিট করে বা কোন মডেলটা ভালো এখানে। কিন্তু যেহেতু as you are not given the raw data, then how will you proceed and how will you decide that which model is better fitting the sample data between these two model? এখন আপনি আসেন মেইন কম্পারিজনে। আর স্কয়ার দিয়ে কম্পারিজন করাই যাবে না, বিকজ both of them are in the different form. গ্রাফিক্যাল প্লটও আমি করতে পারছি না, বিকজ I am not given the raw data. Then how would I proceed? কি করব তাহলে? In that case, what you have to look after is, from the output given from these two model, given from these two model, first of all you have to look after the sign of expected sign of the coefficient, not sign of the expected coefficient, expected sign of the coefficient. Or expected sign of the elasticity coefficient. কারণ আমাদের তো দুইটা মডেল, for the first model, linear model, it is known as slope coefficient. Later model, log linear model, it is known as elasticity coefficient. Okay, একটা হচ্ছে elasticity আর একটা হচ্ছে slope. So expected sign of the coefficient that you have given in these two model, you know that price and consumption or price and demand for the coffee would be inversely related as per your economic point of view, তাই না? Economic point of view টা কি মিন করে, যে যখন কফির প্রাইস ইনক্রিজ করবে, when we will increase the price of the coffee, definitely the consumption will be decreased because of the less demand of the coffee, isn't it? So it means
Yes,
there
sir.
is an inverse relationship. economically or theoretically, there is an inverse relationship between price of the coffee and consumption of the coffee. If it is economically negative relationship, then definitely the coefficient sign or the sign of the B2, sign of the elasticity coefficient or a slope coefficient would be also negative. In model A, it is found negative. In model B, it is also found negative. So both models are showing the right expected sign of the coefficient. তাহলে এটা দিয়েও আমি চুজ করতে পারলাম না। কেন পারলাম না? Because both model are showing the right sign of the right expected sign of the coefficient. এটা বুঝতে পারছেন তো? This is the third parameter that will guide you how between these two model, linear and log linear model. যদি এরকম হতো যে একটা মডেল শো করছে, one model is showing the positive sign of the coefficient, another model is showing the negative sign of the coefficient, then you are done. Then you can easily choose that the model which is showing the negative sign of the coefficient, that is the right model, whether it is linear or log linear. Okay, কিন্তু সেটাও আপনি এখানে পাচ্ছেন না because both models are showing the right expected sign of the coefficient. Negative sign হওয়ার কথা, দুইটাই negative show করছে. Okay, after that statistical significance. Statistical significance of your slope coefficients and elasticity coefficients. Statistically significant কিনা দেখতে হবে কোনটা, the coefficients, the slope coefficient from model A and elasticity coefficient from B, both of these coefficients are statistically significant or not, you have to justify it. And statistical significant আমরা কিভাবে জানি দেখি, using what, t-test, t-test দিয়ে দেখি। তো t-test দিয়ে দেখার পরে দেখি কি দাঁড়ায়, এটা পাশেই করি, হ্যাঁ তাহলে একটু সুবিধা হবে। If we take the t-test of this one, so our null hypothesis, let h0 is beta 2 equal to 0, h1 beta 2 not is equal to 0. আচ্ছা, আমি তো এখানে টু টেল টেস্ট দিলাম, এটা কি টু টেল টেস্ট হবে? Is it followed by two tail test? না, নাকি one tailed হবে? আমরা কি জানি? আমরা জানি যে this coefficient should be always negative. According to what? According to
economic theory,
economic point of view or economic theoretical point of view. So আমরা এখানে আসলে আমাদের হাইপোথিসটা ধরতে হবে এভাবে, one tail, exactly. খুব সূক্ষ্ম ব্যাপার আসলে, এগুলো খুব খেয়াল রাখতে হয়, কারণ so it would be less than 0, to be greater than or equal to 0. So this is our null and this is our alternative hypothesis set, okay, and followed by the one tail test. Okay, and then just write down the value of your sample estimator B2 minus the null hypothesized population parameter value divided by standard deviation of the B2. So you are given the value here. Your B2 value is 0.4795 minus 0 is the null hypothesized value divided by standard deviation of the B is 0.1140. And then now you will calculate your t value. T value টা কত দেখেন তো?
4.21.
Sorry, কত?
4.21, sir.
4.21. আচ্ছা। Now you'll have to test it whether it is statistically significant or not by observing the value at the end of your text in the critical values of the t table.
ভ্যালুটা নেগেটিভ ধরবো?
Sorry?
স্যার এখানে b2 এর সামনে যেমন মাইনাস লিখলাম,
হ্যাঁ হ্যাঁ, এটা তো মাইনাস সাইন থাকবেই, বাই ডিফল্ট আছে এটা -4.21. ওয়ান টেল তো আমরা শুধু মাইনাসের দিকে দেখব, একই কথা। So here in the statistical tables at the end of your text, according to your critical values of the t, your here degrees of freedom কত হবে? your degrees of freedom would be followed by n minus কত?
So 2 হবে
How many
এখানে।
parameters are there? 2.
2
Yes.
হবে 2।
N minus k, that means 11 minus 2 is equal to 9. So look at the degrees of freedom corresponding to the 9 for 5% level of significance for a one-tail test. The critical value is showing 1.833. Not so as critical value is showing value at 5% level of significance is 1.833. ঠিক আছে না ভ্যালুটা? একজন একটু খেয়াল করেন 1.833 and our calculated value is so it is minus 1.833 actually, because we are dealing with the negative values, minus 4.21. So here t value is 0 on the middle. Here the value is minus 0.421. Say this is the level up to which you can accept the null hypothesis, minus a 1.833, and your value is found 4.21, which is your calculated value, minus 4.21, which is fallen under the level of significance area. So we what? We reject null hypothesis, isn't it?
Yes, sir.
So if the null hypothesis has been rejected, so beta 2 value is less than 0, it has been rejected. So it means the coefficient is statistically significant. Okay, it is statistically significant. So here, one thing is, once you have found that this is your statistical significance for the model A, similarly you will get the value of a statistical significance for model B. The model A and B, for both of this model, once you have found that slope coefficient as well as elasticity coefficient, both of these are also statistically significant. যদি এরকম হতো, it is not statistically significant, but for model B it is statistically significant, then you can easily choose that model B is superior to model A. But here if both of the elasticity coefficient as well as your slope coefficient are found statistically significant, then what would be the next approach to choose your model? And এখানেও you have been failed to identify which model is good or which model is better than other. আমার কথাটা বুঝতে পারছেন?
Sir, কোনো একটা model insignificant হলে we would choose that, right?
Exactly. The last one, if you are not making any decision depending on the statistical significance of the coefficients also, then how do you proceed? The last one is by calculating the elasticity coefficient for elasticity coefficients for both models. By calculating elasticity coefficients for both models. Okay. So for model A, you have already calculated the elasticity coefficient for model A. You have already calculated, it is কত জানি আমরা ক্যালকুলেট করলাম না এটা? Using the average value, y bar and x bar value for model A, the average elasticity is found minus 0.2190. Okay.
Yes, sir.
And elasticity for model B, it is already given here, it is already calculated here, it is for minus 0.2530. একটা হচ্ছে -0.21 আর for model B হচ্ছে we have already given it is -0.2530. The elasticity between these two models, which is showing the higher amount, that this is shown as -0.21, that is shown as -0.2530. দেখতে পাচ্ছেন তো?
Yes, sir.
মানে মাইনাস দিয়ে চিন্তা করলে এটা আবার কম, মানে আপনাকে চিন্তা করতে হবে যে আমি বলেছিলাম যে গ্রাফিক্যালি প্লট করলে ইউ ক্যান নট থিঙ্ক অ্যাবাউট দ্য মাইনাস সাইন। When you are calculating elasticity, the value of elasticity would be greater than 1, less than 1, or equal to 1. তো এখানে যখন আমরা ক্যালকুলেট করব elasticity value, we are assuming by default it is positive value having. But mathematically, when we are replacing the value of elasticity, definitely there should be a negative sign. So here the last point of discussion is when you are calculating the elasticity coefficient for both model, the model which is showing the higher elasticity, that would be the good model, or that would be the preferable model compared to the earlier one. So এখানে দেখেন, for model A, when you have calculated the price elasticity, it is found -0.21, and for model B, it is already given -0.2530. So if we just ignore the minus sign here, the elasticity coefficient for model B is higher than that of the model A. So in that case, our conclusion is model B is preferable to model A. Okay,
Sir, can we just simply follow the last method always?
last.
Can we simply follow the last method always for determining fitness of good?
Yeah, you can follow that the last method, but it is actually step-by-step methods. So if you are given the raw data, you cannot just go to the last method. Okay, you have to start from the beginning one. You have to plot them against y against x, or ln y against ln x. Then you can decide. You can decide very easily if you are given the raw data. But if you're not given the raw data, you can directly move to the last one by calculating the elasticity coefficients for the model. Okay.
Okay, sir.
চোখে দেখে, মানে if you just by observing, because of the expected sign of the coefficient, you can just observe it between these two models and can decide which model is preferable to another. So চোখে দেখেও আপনি ঠিক করতে পারেন যে expected signটা ঠিক থাকলে তখন আপনি বলতে পারবেন যে yes, model B or model A is better than the other. আর statistical significance এর জন্য always you have to show your calculations. Okay. So up to this is for today. We have some other models or other forms of model will be discussed in the following class. I will take a class on the Thursday also, day after following. I will take another class at the same time at 3 p.m. So আপনাদের অসুবিধা নাই তো? অসুবিধা থাকার কথা না, আপনারা বসেই তো আছেন বাসায় নাকি? So in the Thursday, day after following, I will take another class, okay, for the rest of the different forms of regression model.
Okay, sir.
Okay, so till now, I think it's clear to everyone, the whole calculation of this problem and the discussion of the solution of this problem. And it is about only discussion about the log linear model. We have some other 4 models also: semi-log model, link log model, reciprocal model, and regression through the origin model. So 4 other models will be discussed in the following class. So let me take your attendance. আচ্ছা, আরেকটা জিনিস, the output we have estimated for a multiple log linear model in the earlier session. If you want to go for any diagnosis test, I'm just writing the comments here, or just showing you the path that how you conduct the diagnosis test of this data set. আপনি এখানে যে আউটপুটটা বের করেছেন, এইটার যদি diagnosis test করতে, whether the model is good or not, or it suffers from any diagnosis problem like we have shown in the earlier class, multicollinearity problem, heteroscedasticity problem, or autocorrelation problem, then you can simply do this by pressing from the menu bar statistics, then from linear models and related regression diagnostics, specification test. So first of all, test for heteroscedasticity, it's given by default in the first one. So just give OK. So then the chi-square value is given, p value is given. Your null hypothesis is heteroscedasticity problem arises when there is no constant variance. There is no constant error variance. So null hypothesis is error variance follows the constant variance. So according to the value of your p value of your chi-square test statistic, it is statistically insignificant at 5% level because the p value is 0.08 and our level of significance is 0.05, 5% level. So it is more than that. So in that case, our conclusion is we have been failed to reject the null hypothesis, or alternatively, our null hypothesis is accepted. So here, the model does not suffer from the problem of heteroscedasticity. It follows the homoscedastic error variance. So this is one diagnosis test you can do. Another one is for multicollinearity test, you can calculate the variance inflation factor for the independent variables. So VIF. So VIF value is given, it's very high. Can you see? Mean VIF is 29.12. So the model suffers from the problem of multicollinearity problem. Okay, I told you that the standard benchmark for the multicollinearity test statistic of VIF is 5. But if 5 এর যদি বেশি হয়, the value of mean value of the variance inflation factor, if it is found above 5, then the model suffers from the multicollinearity problem. Multicollinearity means the correlation among the explanatory variables. এখানে দুইটা explanatory variable আছে, একটা employment, একটা fixed capital. So there is a correlation between these two variables, and it's high correlation. Okay, and that's why the VIF value is very high, 29.12. Another test statistic you can do for diagnosis test is for autocorrelation, which is followed by Durbin-Watson test. And here the autocorrelation command would not be followed by the panel data set that I have shown you in the last class. It is followed by the Durbin-Watson test, DW test, we say. We will talk about in detail about DW test in the later. So just press Durbin-Watson D statistic. It is found 0.425614, which is also showing that the model suffers from the problem of autocorrelation. Autocorrelation means I told you that error terms are correlated. Error terms of the model are correlated. Error terms of the model from one time to another time are correlated. So in that case, how would I actually conclude that these DW test statistic producing 0.4256 value, which actually concludes that the model suffers from the problem of autocorrelation. Its benchmark is D value will be always equal to 2 or close to 2 for not having any autocorrelation problem in the model. If it is less than 2 or greater than 2, or if it is not close to 2, মানে এমন যদি হয় যে if your value of D statistic is found 0.195 something, so then the model doesn't suffer from the autocorrelation problem. But if it is found 0.15, like here 0.4256 or 1.15, then definitely it's far away from the 2, and in that case your model suffers from the problem of autocorrelation. Okay, and last one I told you that another diagnosis test you can do is model specification test, whether your model included all the relevant explanatory variables or not. You can also test it using the Ramsey regression error specification test or reset. So if you just make the reset, press the reset button and press OK, then you can see that Ramsey resets null hypothesis was model has no omitted variables, and according to the p value of the F test statistic, it is found that F test statistic value is 0.0000. That means it is less than 0.05 of our level of significance. So we can reject the null hypothesis. And if we reject the null hypothesis, so what is the conclusion we can draw here? Models is misspecified or model clearly specified. Or we can say model does not suffer from the specification bias, or model suffers from the specification bias. কি কনক্লুশন ড্র করতে পারি বলেন তো, নাল হাইপোথিসিস যদি রিজেক্ট করি রামজেতে আমরা?
স্যার মডেলের স্পেসিফিকেশন বায়াস আছে মডেলটার মধ্যে।
Exactly. So your null hypothesis is model has no omitted variables. যদি no omitted variable থাকে, there is no specification bias. So we are rejecting the null hypothesis. So we are rejecting there is no specification bias. This statement has been rejected. That means alternative is there is a specification bias. So model suffers from the specification bias problem. So these are the 4 diagnosis tests you can do for any regression model. So that is what I was actually showing you. Now I'm taking your attendance. So first of all, from the insurance stream, response please from the insurance stream. Roll number 4. Insurance stream, roll number 4. Roll number 20. 25. 25. Roll number 32. Roll number 38.
Yes, sir.
43.
Yes, sir.
59.
Sir, yes, sir.
60.
Present,
60.
sir. Present, sir.
67.
Yes, sir.
87.
Sir.
100. Roll number 100. 103.
Sir, 25 asi, sir.
Okay, 25. You're present. Roll number 100. 103. 103. 110. 106. 106 আছেন?
Sir, 103 achi, sir. Yes, sir.
Okay. 106. 110. 110. 116. 118. 124. 127. 27. 130.
Yes, sir.
135. 135. 139. 139. 140. 141. 144. 144. 171.
Yes, sir.
174.
Yes, sir.
76.
Yes, sir.
180.
Sir, 133.
Yes, sir.
133 এখনো কল করি না, ওটা ইন্স্যুরেন্স স্ট্রিম চলতেছে এখন। 181.
Yes, sir.
184.
Yes, sir.
86. 190. 192. 192. 193. 193. 195. 197. 198. 270. 270. 271. 361. 363. 364.
Yes, sir.
401.
Yes, sir.
81 from 21st.
Present, sir.
97.
Present, sir.
27 from 21st.
Yes, sir.
Okay. Anyone left from the insurance stream?
Sir, ID 20.
Sir, 127.
ID 20, ID 127. Anyone left from insurance stream? Okay, so the students of insurance stream can leave. Now respond please from the banking stream. Response roll number 2. Roll number 2 from banking stream. Roll number 3.
Present, sir.
Roll number 5.
Present, sir.
Roll number 6.
Present, sir.
7.
Yes, sir.
Yes, sir.
9. 10.
Yes, sir.
11.
Present, sir.
13.
Present, sir.
14.
Yes, sir.
15.
Yes, sir.
16.
Yes, sir.
17.
Present, sir.
19.
Present, sir.
21.
Present, sir.
22.
Yes, sir.
24.
Yes, sir.
26.
Yes, sir.
29.
Present, sir.
30. 31. 30 achen?
Yes.
Roll number 30. 31.
Yes, sir.
33. 33. 4.
Yes, sir.
36. 36.
Present, sir.
37. 37.
Sir, 36 present.
দিয়েছি 37 আছেন 39.
Yes, sir.
41.
Yes, sir.
42.
স্যার ছিল স্যার 42 ছিল ডিসকানেক্টেড হয়ে গেছে
আচ্ছা 44.
Yes, sir.
46. 47.
Present, sir.
48.
Present, sir.
49.
স্যার 49 ডিসকানেক্টেড হয়ে গেছে
Okay. 50.
Yes, sir.
51.
ইয়েস স্যার
52.
ইয়েস স্যার
53. 53. 54.
Yes, sir.
55. 55. 56. 57. Okay. 57. 58.
Yes, sir.
62. 63.
Yes, sir.
64.
Yes, sir.
65. 69.
স্যার
Yes, sir.
65 ডিসকানেক্টেড হয়ে গিয়েছে
Okay. 71.
Yes, sir. 71.
74. 74. 75.
Sir, 50.
76.
ছিল ডিসকাউন্টেড স্যার
Sir,
75 ডিসকানেক্টেড হয়ে গিয়েছে
Sir, banking 53.
Okay. Okay. দিয়েছি। 3 দিচ্ছি।
স্যার ব্যাংকিং 46
হ্যাঁ 46
sir.
দিয়েছি।
Disconnected হয়ে গিয়েছিল banking 53.
হ্যাঁ 53 দিয়েছি। Roll number 76.
Yes, sir.
77.
ইয়েস স্যার
80. 80. Roll number 81.
স্যার ও ডিসকানেক্টেড হয়ে গেছে
Okay. 82.
yes, sir.
84.
ইয়েস স্যার
85.
Present, sir.
Sir,
80, G. 87.
Yes, sir. Sir, 87.
Okay.
ID 55.
ID 55 দিয়েছি। It's given. 55 given. Roll number 88.
ইয়েস স্যার
90,
Yes, sir.
91,
Yes, sir.
92, 92, 93, 93, 94,
Yes, sir.
95,
Yes, sir.
96,
Yes, sir.
99,
Yes, sir.
101,
Present, sir.
2,
Yes, sir.
104, 8, 108, 109,
Sir, 93, banking.
okay, দিয়েছি 109, 110, 11, okay, 112,
Yes, sir.
13,
Yes, sir.
14, 115,
Yes, sir.
22,
Yes, sir.
117,
স্যার 17 প্রেজেন্ট ছিল কিন্তু স্যার ডিসকানেক্টেড হয়ে গিয়েছে।
okay,
স্যার
123,
104 প্রেজেন্ট ছিলাম স্যার, ফোন অফ হয়ে গিয়েছিল।
104 were present, okay.
থ্যাংক ইউ স্যার।
123,
Yes, sir.
28,
Yes, sir.
129,
Yes, sir.
131,
Yes, sir.
32,
Yes, sir.
133,
Yes, sir.
34, 134, 138,
Yes, sir.
149, 149, 50,
Yes, sir.
172,
Yes, sir.
173,
Yes, sir.
175,
Yes, sir.
77,
Yes, sir.
178,
Yes, sir.
179, 182,
Yes, sir.
183,
Yes, sir. স্যার আমার একটা অ্যাবসেন্ট দেখাচ্ছে স্যার, আমি তো সবগুলো ক্লাস করেছিলাম স্যার।
কোনটা 183,
স্যার জি স্যার, সবগুলো ক্লাস করেছি। থ্যাংক ইউ স্যার।
okay. So anyone left from the banking stream?
স্যার ব্যাংকিং আইডি 30 ডিসকানেক্টেড হয়ে গেছে।
30, 30,
জি স্যার।
okay, done. Anyone? Okay then, see you next class on Thursday.
16 স্যার লাস্ট ক্লাসে ছিলাম স্যার।
Sorry?
16 স্যার লাস্ট ক্লাসে ছিলাম স্যার এটা।
Okay, done. Okay, so next Thursday, 3 p.m., okay? We'll see you in the next class. Take care.
থ্যাংক ইউ স্যার। আসসালামু আলাইকুম স্যার।
Walaikum salam.
Thank you, sir. Thank you, sir. Assalamu alaikum.
Walaikum salam.